we can just remove the
So a
square
random
root
variable is a
and just do
numerical
B squared
measure
minus
of the
4ac,
outcome of
and
a
that's
probability
because
experiment. So its value
we
is
can just
determined by
factor that in
chance.
at the end.
So if we flip
So
ahead,
we don't know what b
label
is, obviously.
getting
That's
heads
what
is
we're trying to
1,
find. So b squared
2
minus
or
4
3 or
is
0,
negative
depending on how many
91.
times we flip ahead.
Oh, sorry.
So let's say we flip ahead 6 times and we want to
B
know
is
how many heads we
64.
got. 3 would be the random variable.
And c is
Or
25.
how many times we get head.
And that has to
So
be greater than 0.
there's a
So all we
difference
did
between
was
discrete and
plug,
continuous random variables,
two
and we talked about
values
this
into
before,
here.
where discrete is one
So
finite
b squared
point,
has
and
then we can
continuous
just
is
move this
not.
to the other side. So b squared has to be greater than
So it's important to note that rational numbers
um,
aren't discrete at all
positive
because you can't really plot them.
25.
And here we just have a
that
source
I
of
want to
error.
calculate.
So even though radar gun
Get
may report the
6400.
speed of a car
So b
as
squared
discrete,
has to be greater
there's a
than
source of error which makes it continuous.
and we simply square root both sides. Now,
So
when you
here's how
square
we
root
identify discrete
a,
probability
um,
distributions. The
when you
probability
square root
distribution
in
of a
order
discrete
to
random
find a
variable x
squared
provides the
variable,
possible
you typically
values
do
of the
plus
random
or
variable
minus.
and their corresponding
But in this
probabilities.
case, we're just going to do plus.
So
because
if we get heads 2
or
times,
it doesn't really
or if we
matter.
flip ahead,
And
if we flip a coin
here
10
we'll see
times,
that. So
you might get
b
5
has to be greater than the
heads
square root of
90% of the
64,000,
time. 4
which is
heads,
simply just
5%
plus or
of the
minus
time, 3
80.
heads 2.5% of the time, and so
So
on and so forth, and that's what probability
it can
distribution
be
is.
plus or minus 80.
So let's say we flip a coin
and
6
yeah,
times.
that's the answer.
We might get
Right.
3 heads 51% of the time,
Okay.
2 heads 0.38 or 38% of the time, and as we know, all the probabilities must add up to 1, and each probability must be higher than 0 or less than equal to 1. If they're 0, then you don't count them in the probability distribution. So to graph discrete probability distributions, the horizontal axis represents the values of the discrete random variable, and the vertical axis represents the corresponding values. In other words, the y-axis should have the probabilities, while the x-axis
If you can't
should
solve
have
this SAT
the
question,
random
you're
variable.
done. And this one's pretty simple.
Here we go.
But a
If
little
someone
bit more
shoots
complex.
free
and
throws, they
easier
might get
ones.
they might
We'll
hit
get
all
this
3 half of the
difficulty
time,
rating about
to
a 3 out
40%
of
of the
5.
time, and
So
1
the
10%
given
of the time.
equation b is a constant. When it's a
So how do we
constant,
compute and
just
interpret
means
the
that
mean
the
of a discrete
variable
random variable?
b
So when we
is
remember
not
when
a
describing the
variable.
distribution
It represents
of a variable,
a
we describe the
mathematical
center, spread,
constant
and
or a
shape, which
numerical
occupies
constant.
center memory.
Sorry,
We
that's
use the mean to
sounded
describe the center
So
and use the
basically
standard
that means
deviation
b
to describe
doesn't
the spread.
change
When
like
calculating the
x
mean, you can use the
or
formula
another
value of
variable
data
that you
points
would
divided by
typically see
number of data
within a
points.
function.
So
For which of the following values
so
of b
if
will
we
the
do
equation have
like
more than one
GPA
solution?
and A is
So
worth
for
4
quadratic,
points, and
we
let's say we
determine
get
the number of
2
real
A's, we
solutions
get
by
2 times 4
determining what
divided by 2,
discriminant
which is the
is.
number of data points, or the frequency,
And
which will
that
give you the
means
overall
that it can
GPA
have
or
3
mean,
options.
because GPA
If
is
it's greater
simply a
than
mean
0, it has
of
2 real
all the grade
solutions. If
points,
it's equal to 0, it
or
has
the grade
one
point
real
average.
solution. And if
But
it's equal
another
to
way
0,
of
it
finding the
has
mean
two
is each
imaginary
value times the
solutions.
proportion, and here's
here
how
we're
we'll
given
show this
that
mathematically.
it has to
Let's
be
go over to Sketchpad.
more than one real solution,
And
and that means 2 real solutions.
we'll draw
which
this
means
out.
that it has to be greater than 0.
So we wrote the formula
And
as
basically b squared minus 4ac has to be greater than 0.
each value times the
And we
proportion.
just plug in the
So we'll do
values that we
EB for
know.
each value
And
times the
as you can
proportion.
see, we're trying to
which
find
will
b,
be-
so that still
we can
remains
simply write
b
this
squared
as
because we don't know what b
each
is.
value
But we do know what a and c is, which is
times
64
times
25.
random value over
Has to be greater than
proportion.
0. Now this is
Or
just the same
RV over
thing with the values
proportion,
plugged in,
actually.
yada yada.
Or
You
sorry,
just move
RV
this to
over
the
number
other
of trials.
side by adding it, and that would be b squared.
So,
is greater
let's
than
say,
64, 25. Pretty simple so
We get
far.
3 heads.
Now b squared.
So we have 3 here.
What,
And
now we're
let's
gonna
say we
square
get
root
that
both sides.
2 out of 10
and
times.
this just evaluates out to
Simply
b
put,
is
the
greater
probability
than
of getting it
or
is 6 out of 10.
25. When you
So this
square
is simply
roots
another
find
way
the
of
square
calculating the
variable,
mean, because
you
it's
have
the
to do
same
plus or
thing
minus.
as
and in this
each
case, it
value
won't really
times the
matter.
proportion, which is
So b has to be greater than
how much it
square
contributes to the actual
6400,
thing. So 6 out of 10 would be
which is just going to be 80.
would
So b
be
has to
the
greater than plus or minus 80. And it doesn't
a grouped
really matter
frequency
which square
approach.
is greater than plus or minus 80.
So
So now the
probability
question
form is simply the
states,
same
for
thing
which of the
except the
following
value
values
of
of
proportion
b-
such a number of trials.
So we know that
First
b
you get
can
the
be
fraction
any
and multiplying and
is
adding
greater
them up.
than 80.
So
Or plus or
simply
minus.
put,
Which of the following values of b will the equation have more than one
let's
real
rewrite this because I
solution?
think I made
So,
a little mistake.
um,
Here's the formula right
b
here.
has
Each
to be
value
greater
would
than
kinda just be the same
80,
thing as some
or it
notation
has to
notation,
be
which
less
just means
than
that you
negative
add up
80.
every
And the reason
data
is
point.
because when it's negative 81 and you square that,
And
it
we'll
becomes
do,
positive. making
each
that
value,
numerical value
so
higher.
value
However, if
times
you
the
were to
frequency.
add to negative 80 and
So
get
the reason
negative
this works is
79,
because the
negative
proportion
70,
is
and
the
you square
same
that, it's going
as
to be less than
the
than
proportion
the
is
more
the same
negative number,
as or
pretty much.
proportionate with the number
So
of
when you're
trials,
dealing
and that's a little
with
bit difficult to understand, but
a quadratic or
let's
square
say the
variable,
proportion is
it's
2 out of 12.
you get a higher value and a higher, more
That's the
positive
same out of 1 out of
values with the
6.
more negative
That means the
number
other
as the variable.
the other
It's
data
crazy.
points must
It's
have to be 5 over 6.
And
And
so we know
the
that
reason
has
why
to be
this is
greater than
significant
80
is
or less
because
than negative 80. So as you can see here, there's nothing
1 out
that
of
is
6
greater than
measures
80.
how many
And
times this pops up.
There
So if
is
you multiply
something
the
that is
value,
less than
you're
negative
simply
80,
doing
and
all
you
the
see
values
here
divided
it's
by the same denominator, which
negative
is the
90.
trials. So it's the same as 6,
it.
which we can set
see
as the
you on
number
the
of
next
trials
one.
because the trials remains constant over a proportion times the value times the frequency of the data point, which we can just assume is 1 here because, well, it depends on the proportion. So if tails appears 3 out of 6 times, then we would multiply the top by 3, or you can do the same thing as 3 out of 6 equals 1/2 and simply truncate it to 2 trials. But anyways, that's why that works, because the trials remains constant over all the summation notation, and that would be the denominator, and then you just multiply that. So it's a little bit difficult to understand, or it's not difficult to understand, it's difficult to explain, but just know that summation is this, or the mean is the same as each value times the proportion. So what's the interpretation of the mean of a discrete variable? Suppose an experiment is repeated n independent times and the value of the random variable x is recorded. As the number of trials increases towards infinity, the mean of the n trials will reach the mean of the random variable. So the classical method gives us, so it's simply the law of large numbers. That's important to note. But also, this gives us the probability, the classical method gives us the probability all the time, assuming equal probability. So let's say we're flipping a die, a fair die actually, and that's what you'll hear in a lot of statistics books because, I guess some die can be unfair. So there's 6 possibilities. There's 1, 2, 3, 4, 5, 6. So let's say we run this trial 5 times, and let's say we get 4, 4, 3, 2, 1. So pretty simple. I'd use some pretty easy numbers, and we'll find the mean or average. We can use the proportion approach because each is 1/5 of the total points, but we'll just use this to make it simpler. So doing some quick math, this will be 8, 11, 13, and 14 divided by 5, which is 2.8. So the mean is 2.8 out of 5 trials. But note, as we increase this to infinity, the numbers become a lot more accurate. So if we do 10 trials, actually let's just do like 24. We're probably going to get 4 times, 2 1 4 times, 1 4 times, 5 4 times, 3 4 times, and 6 4 times. So this is more accurate because if we take the average, we get 3.5. So simply put, as the number of trials approaches infinity, the more accurate mean there is. And we'll learn about expected values in the next one. So let's interpret the mean. Here we have an example, and it's the same example I gave you. In other words, the mean of rolling a die will give you the mean value of 3.5. But what is an expected value? And it's a little bit different. In this term, we discuss the number of trials. And we'll use a way simpler example. Let's take a coin here. And let's assume it's a fair coin, obviously. And let's flip this coin 10 times. Well, on average, what would you expect to get? And on average, we use the proportion formula, 10 times 1/2, or the expected value formula. And the expected value formula is simply trials times probability. And this simply gives you the amount it will occur within those trials. So if they're all independent, then we can calculate how many times you get head out of those trials because they're all independent trials. So we'll get 5 heads, right? On average, if we flip a coin 10 times. However, that's not what's going to happen if you flip a coin 10 times. It could happen, but sometimes you may get 6 heads, or even 7 heads, or even, on a very rare case, 10 heads. But on average, the trials times the probability will give you how many times you will get that random variable. On average, and that's what the expected value is. So simply put, the expected values is the number of times you will get your variable in those amount of trials, and that's dependent on the trial. So if we upped it up to 100, we'll get 50 hits, and so on and so forth. So here's the standard deviation of a discrete variable, and it's simply the same formula, easy to understand. And since the proportion is the number of trials, it's the same thing. So let's draw this mathematically, and as we know, the formula is x minus sigma, I believe. So x minus standard deviation, which I don't know how to draw. So we'll just write dev squared times proportion, or I guess p of x to represent proportion. But note that p of x is simply the same as 1 divided by n, or yeah, actually it's 1 divided by n. If you simplify n down to its simple fraction. And this is just the same formula, mathematically. So, that's how it works. But we use p of x because if it's 2 out of 12, so if you get a certain value 2 out of 12 times, you just multiply it by 2 instead of doing this twice, because it would be the same value. So if it's 2 minus standard deviation squared, and we have 2 that appears twice in the data set, we're simply just going to add them up. And instead of adding them up, you can just use some simple algebra to denote that it's the same as 2 times 2 minus the standard deviation squared. So it's some simple algebra, but they're the same exact formula, and you won't really have to worry about that because most stats class will actually use your calculator to understand this, so that's it.